Cosmic dust highways, the silent architects of the universe. When you picture space, what comes to mind? A cold, empty vacuum, a vast expanse of nothingness dotted by a few stars and planets? While this might be the most common depiction, the reality of space tells a far different story. Far from empty, space is teeming with invisible streams of particles known as cosmic dust highways. These sprawling, interconnected networks silently crisscross galaxies, connecting stars, planets, and everything in between. Yet, despite their microscopic size, these grains are anything but insignificant. Created by some of the most powerful cosmic events, like exploding supernovae, icy comets, and dying stars, cosmic dust may have delivered the critical ingredients for life as we know it right here on Earth. These particles shape galaxies, influence star formation, and may even have profound effects on our own solar system. In this video, we'll take you on a journey that reveals the profound yet hidden role of cosmic dust highways, the silent architects of the universe. To understand cosmic dust highways, we must first explore what these dust particles actually are. Cosmic dust consists of tiny grains of matter, often smaller than a grain of sand. These particles can be made of a wide variety of materials, including minerals, silicates, water ice, and carbon-based compounds. What makes them extraordinary isn't their size, but the roles they play in the vast tapestry of the universe. Individually, these particles seem insignificant, but together they form vast, interconnected pathways that stretch across galaxies. Astronomers often compare these highways to rivers, flowing with the small components of matter that build planets, stars, and even the seeds of life. While invisible to the naked eye, cosmic dust shapes the very destiny of celestial objects, and perhaps even life itself. But how do these highways form? Cosmic dust originates in some of the most dramatic phenomena the universe has to offer. For instance, supernova explosions, the violent deaths of massive stars, eject massive amounts of dust into surrounding space. These high-energy events scatter elements like carbon, oxygen, and silicon, which then coalesce into microscopic dust grains. Similarly, dying stars, including red giants, slowly shed their outer layers over millions of years, releasing dust in a quieter but equally important process. Comets are another contributor to cosmic dust. As these icy wanderers travel through space, their surfaces evaporate when exposed to heat, leaving a trail of dust in their wake. Over time, these particles become part of larger highways, carried away by the solar wind or the radiation pressure from stars. Once ejected into space, cosmic dust is not stationary. It travels guided by powerful forces like gravitational pulls and interstellar winds. Over time, these forces shape the dust into coherent pathways, often linking entire regions of the galaxy. These flows can stretch for hundreds or even thousands of light years, connecting stars, planets, and nebulas in unseen but profound ways. What makes cosmic dust truly fascinating is its role as a building block of the universe. Consider the formation of stars and planets, processes that are impossible without these tiny grains. When interstellar dust gathers in dense clouds, these regions become nurseries for stars. Over millions of years, gravity pulls these dust particles closer together, and when they collapse under their own weight, they ignite to form new stars. Similarly, during the early stages of planetary formation, dust particles collide and stick together, forming larger and larger clumps. These clumps eventually grow into planetesimals, which are the precursors to full-sized planets. Beyond structure, cosmic dust highways are also essential as carriers of elements of life. Dust carries vital compounds such as carbon, nitrogen, and water in the form of ice. These elements are fundamental to the chemistry of life. In fact, some theories suggest that cosmic dust particles delivered these ingredients to a young Earth billions of years ago, possibly kickstarting the very first forms of life. Cosmic dust also plays a role in creating the breathtaking sights we associate with space, like glowing nebulas. These clouds of gas and dust owe their beauty and structure to the tiny particles that reflect and scatter light. So even the universe's most stunning visual phenomena wouldn't be possible without these tiny architects. It's astonishing to think that the microscopic grains drifting through space might have seeded planets with the potential for life. Scientists propose that early in Earth's history, cosmic dust from comets and asteroids bombarded the planet, delivering water and organic molecules. These events could have left behind the precursors to amino acids, the essential building blocks of proteins and life. This hypothesis isn't just speculation. Evidence supports it. Some meteorites studied here on Earth are found to contain organic molecules that predate our planet. Interstellar dust, collected through high-altitude equipment and space missions, also reveals traces of carbon-based materials. These findings suggest that the same cosmic dust that fills the universe's highways may have altered the destiny of our planet and others. If this is true, then cosmic dust highways don't just connect celestial objects, they connect us. These tiny particles formed in the fiery deaths of ancient stars may have sparked the very chemistry that allowed life to emerge on Earth. While much of the discussion centers on the broader galactic scale, cosmic dust highways affect our solar system as well. One clear example is the zodiacal light, an ethereal glow that appears just before sunrise or after sunset. This phenomenon occurs when sunlight scatters off interplanetary dust particles in our solar system. Dust isn't merely a passive presence either. It dynamically interacts with planets, comets, and even our sun. For instance, particles from cosmic dust contribute to the micrometeoroids that occasionally burn up in Earth's atmosphere, creating the shooting stars we see at night. There's also the ongoing question of how cosmic dust highways influence planetary weather and climate. The thin layer of cosmic dust in our solar system modulates the way light moves through space, potentially affecting how planets like Earth absorb solar radiation. As small as they are, these particles have a far-reaching impact. Studying cosmic dust has been a challenge for scientists, largely because of its microscopic size and its dispersion across incomprehensibly vast distances. However, advances in technology have allowed researchers to uncover some of its secrets. Instruments aboard space observatories like the James Webb Space Telescope and the Hubble Space Telescope have been crucial. These tools detect the infrared light scattered or absorbed by dust, revealing its chemical composition and structure. Space missions have played a pivotal role as well. NASA's Stardust mission, for instance, captured samples of interstellar dust and returned them to Earth for analysis. These missions not only give us physical samples of cosmic dust, but also provide data on its origin and journey. Yet the study of cosmic dust is far from complete. Apart from technical limitations, the extreme diversity of dust types presents a puzzle. Dust grains formed in supernovae differ in structure and chemistry from those originating in comets, and tracking their individual paths across the galaxy requires intricate models and years of research. Despite our progress, many questions remain unanswered about cosmic dust highways. For one, scientists are still investigating how much of the material essential for life across the universe originates from these dust streams versus being formed on planets themselves. Another mystery is whether these highways could have supported prebiotic chemistry, chemical reactions that lead to life, on other celestial bodies, like some of the moons of Jupiter and Saturn. Further, we still don't fully understand how interstellar dust interacts with the environments of exoplanets. Could the presence of abundant dust indicate that a planet has conditions favorable for habitability? These are questions that researchers hope to answer as we expand our exploration and studies of exoplanetary systems. Future explorations will provide unprecedented insights into these fascinating highways. Advanced missions like ESA's Comet Interceptor and NASA's Dragonfly to Saturn's moon Titan aim to study dust closer to its sources. At the same time, telescopes like the James Webb are looking deeper into star-forming regions to understand how dust evolves over time. As humanity inches closer to interstellar travel, cosmic dust highways could become integral to navigation. Mapping these streams might help spacecraft move more efficiently across vast distances, or even provide clues about regions of high scientific interest. Furthermore, the study of cosmic dust could help astronomers refine their understanding of exoplanets. Finding systems rich in dust materials might indicate sites where rocky planets and life-building elements are likely to form. Cosmic dust highways may be invisible to the eye, but their impact on the universe is far from subtle. From forming stars and planets to delivering the ingredients for life, these tiny particles play an outsized role in the grand story of existence. They connect galaxies in a web of creation, acting as silent architects of the cosmos. As research progresses, we are likely to discover even more about how these microscopic grains bridge the vast spaces between stars and shape entire galaxies. For now, though, we are left with a humbling realization. The same particles that helped build our Earth may be traveling countless light years away, bringing the seeds of life and creation to other worlds, weaving the unseen threads of the cosmos we call home.